All right. Questions from homework? 34. Let me go through. 34 says what?
2x cubed minus 2x squared minus 12x equals 0.
Did I write that down appropriately? Okay, so I want to solve this because there's an equal sign, yes? And then if I have it raised to the third power, at this point, that usually means we need to factor out a greatest common factor. It looks like I could factor a 2 and an x from my three terms. Agree?
Yes, sir.
Okay, so I got 2x, and then I have x squared minus x minus 6. Is that right? Mm-hmm. So this right here is just going to give me, is that okay?
Mm-hmm.
And then this is going to factor down. I should be able to do it quickly. I know I have alternating signs, so it's going to be a -3 and a +2. What do you think?
Mm-hmm.
So that's going to yield me 2 more answers. So I get x is equal to -2 and x is equal to 3. Got it. What else do we need to take a look at? Yeah.
27.
27. Could you read that one to me, please?
4x squared minus 1.
4x squared minus 1. No equal sign or anything?
No.
Okay. So when you see 2 terms, you need to kind of start thinking it might be difference of 2 squares. And 4x squared is the same thing as 2x and 2x. So that's a perfect square and 1's perfect square. So this is difference of 2 squares.
Okay.
So 2x plus 1 and 2x minus 1. Is that okay?
Yay.
What else? Yeah.
23.
2, 3. What does it say?
X squared plus 16.
X
I
squared
don't understand how it's,
plus 16?
yeah. I
Okay.
just don't understand why it wouldn't just be like.
Okay. So it's called the difference of 2 squares, right? And this is the sum of 2 squares.
Mm-hmm.
So you can't factor it, so it's prime.
Okay.
If it was this breaks down to x plus 4, x minus 4.
Mm-hmm.
And then here's what a lot of students think. Oh, I think it's x plus 4, x plus 4. Which then that would actually create, if you multiply that out, a perfect square trinomial. This multiplies out to give you this. That should be a 16x, excuse me, plus 16. So if I multiply that out, that obviously doesn't equal that. So this can't work. So the sum of two squares is prime. Yeah.
19.
19. What does it say?
12x squared minus 25x plus 8.
Did you say plus 8?
It's not.
Not equal to anything? Okay. First thing I would look at on this, it's just looking, it doesn't, nothing's perfect squares. I don't have a factor. I can factor out all 3. So this is one I would do by the longer method. So I'm going to multiply those 2 together. So 8 times 12 is that 96? Is that right?
Uh-huh.
And then this is positive. So in order for this last term to be positive, you either have to multiply a positive, or a negative, And being I have a negative sign here, that means both signs have to be negative. So now I need to figure out the factors of 96, that both being negative. That would add to 35. So can I go 32 times 3? Does that work? So give me 96.
Mm-hmm.
Yeah.
If they're both negative, do they add to negative 35? Is that right? Cool. So those will definitely work. So we'll go ahead and plug them in. So this first term will come down. Doesn't matter if I have the -3 first or the -32 first. It'll still come out the same. So we can factor a 3x out here. So that gives me 4x minus 1. This negative has to come down. And here I can factor out an 8. That's going to give me 4x. And the reason this sign is going to change to a negative is I factored out a -8. And so from there I have 4x minus 1 and 3x minus 8. Okay. What else?
32.
32. What does it say?
4x squared minus 2x
equals 0.
Like that?
Yep.
Okay, so that is two terms, so some people will say, well, let's go right to difference of two squares, but it's not difference of two squares because 2x isn't a perfect square. So then you might have to start thinking, okay, can I factor something out of both of those? And the answer is yes. And that's how those would factor. This is going to result in x equals 0, and then this is going to result as x equals 1 over 2. Instead of equal to 0, you'd add 1 divided by 2. Anything else? Go ahead, Riley.
31.
31. What does it say?
4x squared plus 4x plus 1.
Okay. That's one that a lot of students might result in saying, hey, let's go to the grouping method. But this is a perfect square, I believe. And the reason I see that is 4x squared is the same thing as 2x times 2x. And then 1's the same thing as 1 times 1. So I think, but we might be wrong, I think this is going to be this. Okay? Because I have this and this. Those are my perfect squares. So then you just want to double check. If I were to go 1 times 2x and 2 times 1x, or 2x times 1, do I get 4x? And the answer is yes. So that was a perfect square trinomial. Yeah?
14.
What do you got?
X squared minus 11.
Not equal to anything? Just want to factor it?
Yep.
Okay, only thing I can factor out is an x. Done.
Wait.
That's it.
That's it. Yeah. So a lot of times when you have two terms and it's a difference, it looks, you're going to think it's different two squares. But I think most of you can identify that 11 is not a perfect square. Any other questions you might have?
39.
39. What do you got?
8x cubed equals 50x.
8x cubed what?
Equals 50x.
Equals 50x. First thing I would do is I would bring the 50x over by subtracting it. And then I look at it and say, oh my gosh, is this the difference of two squares? Not yet. I could factor a 2x out of both. And that's going to leave me 4x squared minus 25. So this is now going to yield to me x equals 0. So there's one solution. This breaks down to 2x plus 5 and 2x minus 5 because that's the difference of two squares. And then that's going to give me negative 5 over 2. And it's going to give me x equals positive 5 over 2. Is everyone okay how I solve those? I'm doing those quick. As far as 2x plus 5, you'd set equal to 0, subtract 5 from both sides, and then divide by 2.
Just do an easy way of just dividing the multiples of 4. Is that how you get that? Or you?
So once I factor this out, this right here is two perfect squares separated by a subtraction sign, so it's the difference of two squares. Anything else, yeah?
Would it matter if you put, like, that part you just marked, what if you put, like, 4x on the outside and then 2x? Does that make sense?
So you want this to be a 4x here?
Yeah, like, would that matter?
Well, 4 doesn't go into 50 evenly.
Okay. Sorry.
That would just be a setup error. If you did it, so usually when I'm grading this, I'll just tell you, when I go through and grade this, I'm looking for this. If I see that first, I'm pretty much done grading. If I don't see that, then I start working my way back up to see where points can be awarded. Does that make sense?
Yeah.
Anything else? Going once? Twice? Okay, make sure your name is on that and anything else you're handing back in, please.
Well,
I'm just glad that I know that tomorrow's Friday.
Woo!
Yeah.
Yeah, baby. Friday.
Well, that's in 2 weeks.
Wow.
Yeah, you want to. All right, so come tomorrow, we have, we do have a quiz, and I'm just going to tell you how the format of the quiz is going to go. There will be 10 questions on Schoology. So they're all multiple choice. Okay, so we'll use one of the Chromebooks. You'll log into it and go. And what we'll do, just for sake of time and making sure everything's good, because I can tell you that not all of those work as fast as the others. So I would hate for a kid to be sitting there going, it's not loading yet. So, and I don't have enough in there for everybody. So what we'll do is half of you will start on Schoology, and then once you're done, I will get you the test, and I'll go plug your thing back in so the person who gets done with the other part. And then we have a front and back as far as the other, as far as written part of the test. Between the two scores, they'll be kind of put together, so you get 10 points off the Schoology, and then whatever you get out of 10 will be added to your other thing. Does that make sense?
Yeah.
Things that I know might be the things on. There's nothing on this that I don't think you can't do. There's questions that might say, find the vertex. Okay, so you have to do x equals negative b over 2a, and then you plug that in, right? And I'm just doing a real quick review. I'm not spending a period on it. And then it also might have the shifts. Where you know that h comma k is the vertex, and the a value stretches it or compresses it. If it's a number that's larger than 1, it's a stretch. If it's a number between 0 and 1, so a fraction or decimal, it's a vertical compression. It might ask you, did it shift right or left? If you look just at the vertex will tell you if it shifted right or left. So everything on the Schoology part, there's 10 questions, they're multiple choice. I think they're pretty straightforward. There's nothing on there that's a gotcha. On the written part, you will have some factoring. I will tell you that where it will catch up with you on the factoring is if you have to use the longer method to factor every one of them, you're going to run out of time. Okay, I'm just being honest with you. I'm not trying to say that to frighten you, but I would say a really good way to go through the front and back of the paper is go through and do every problem you know how to do. Do those first. Then go back and saw through the ones that you might have take a little bit longer to factor. Okay, that's a really good testing technique. It's not something that's frowned upon. That's something that should hold through to any type of test you do. Go through if you got difference of 2 squares down, go find the difference of 2 squares, factor it, done, and then go back and do the others. But that's just my best advice for you. I don't think it's going to take you much more than a period. As soon as you guys are coming in, I'm going to hand you. I'm going to either say, you'll have either a Chromebook on your desk, and I should have it on, so it's ready to rock and roll for you. You will have to log into my Cherry Creek again in Schoology. Don't go through the other thing. Y'all know how to log on to Schoology, I hope. I get these freshmen going, I've never seen Schoology ever, and you look back and they've gone through our feeder going, okay, you didn't move here from some different state. But that's what I got. All right, sound good? Now today what we're going over will not be on this test tomorrow. The homework from tonight will actually be due on Monday, okay?
What am I doing?
This is so.
What's Olivia doing back behind her notebook? She's on her phone. I saw her just slip that
I
phone.
really don't have my
Totally
phone.
saw it.
Nope.
Nah, she's just studying.
Yes, she
I'm
is.
studying my.
She's either on her phone or
I'm
playing
on my
with matches.
calculator.
There's
Look,
only one of those.
see?
There's only one of those that's appropriate to do in class.
I don't have a phone. What are you talking about? What?
Did I?
Playing with the
Yeah, Pastor. I hope.
Which one is the basis is so weird?
Over there, who's not passing back? Goopers, let's pass those back there, Jim.
Not me.
Wait.
Why do you always on my head? It's never me.
It's always you.
Never.
Always.
Never ever.
It's a good thing you're a good kid. I like you.
Yeah, okay.
Everyone have a note sheet? We're good? And it looks like it. Yay. All right. Simplifying radicals. I think I have an okay way of doing this. You do need to be able to identify what are perfect squares. So 36 is, 100 is, 121 is the same thing as 11 times 11. 900 is 30 times 30. 64c squared is a perfect square because 8c times 8c is 64c squared. Square root of 1440. I'm going to say yes. I can't do it in my head right now, but I think it's a perfect square. Someone double check for me. 1600 is a perfect square. And 1000 is not, because 1000 is 10 times 10 times 10. 10,000 is. And then, is this a perfect square?
No.
Yeah. Absolutely. And what about this?
Yeah.
The reason this is a perfect square is because the square root of x to the fourth is x squared. The square root of y to the sixth is y to the third. Right?
Woo!
Does all those make sense?
Wait.
Why is 49a not a perfect square?
Because A isn't squared.
Yeah, a isn't squared. If it was 49a squared, it would be 7a, 7a. 700 breaks down to 7 times 100, though it has a perfect square as part of it. That's not a perfect square. Can I move off this screen?
Yep.
Cool. All right, vocabulary. Let's see. I do have stuff to remove. There we go. Let's just remove that.
Why do you do that?
Well, the other teachers think it's cutesy.
They're stupid.
Well,
You're too good for them.
all right, vocabulary. Square root. A number r is the square root of the number s if r squared is equal to s. So root a times root a is equal to just a. The reason that works is because a times a is a squared, square root of a squared. The radical sign, the symbol for it is square root. You can also have cube roots, fourth roots. We start calling these nth roots. We can get to the nth root. Okay, so that would be the square root of whatever number you want. The real crazy thing is you can actually have a mathematical equation as the root.
That's crazy.
Yeah, don't worry, you're not going to see that in here.
Nope.
But there are some really weird people out there in the world like, hey, I wonder if you did this. You're like, dude, why? Just let it be.
Yeah,
And then all of a sudden they discover how, like to make, a wireless network off of it. And you're like, oh, I wish you just would have done that.
Yep. Always. All the time.
All right, let's see if I can move this around. Over here. Okay. Move this. Move this. Move this. Anything here? Anything there? I don't know if anything else. All right. All right. The square root of x refers to the positive square root, and the negative square root of x refers to the opposite, or the negative square root. So if you had negative square root 9, the answer is negative 3. Okay, the reason is you have a negative outside the root. It should be still okay. Agree? Moving on. Uh-oh, more stuff to remove. Was there stuff there? Yep, Radicand and, oh, come on, where'd it go? Here, there we go. Good. Is there more here? Is there anything beyond that? I tried to erase it on yours. Okay, the radicand is the number or the expression under the radical sign. So if you had square root of 9, 9 would be something called the radicand. Is that really priority as far as math? No, we're just getting in vocabulary. In the square root of x, 24x is the radicand. The radical is the entire expression. Okay, so square root of 35ab, that could be called radical 35ab. Okay, that's just terminology for you. List of perfect squares less than 125. Can we do it quick? 0 times 0. 1 times 1. 2 times 2. 3 times 3. 4 times 4.
We skipped 5.
5.
No.
You at least get 5.
Oh, never mind. My bad.
Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 11, 12, 13, 14, 15. What's 16 times 16? You have a calculator? 16 squared equals, I'm looking for these answers.
256.
Thank you. So I got 256, 17 squared.
289.
289. 18 squared.
324.
19 squared.
61.
361.
And I got 400. 21 squared.
441.
22 squared.
484.
23 squared.
529.
And 24 squared. 596.
576.
576. And then 25 times 25 is 625. So those are all of our perfect squares. Well, I guess I didn't have to list 625 because we were just looking for less than that. Okay? Does everyone understand how to get a perfect square? Can I move on?
Yep.
The nice thing about this is the difference between here and here, the difference between here and here, the difference between here and here, the difference between here and here. Here to here is 9. So it's the odd numbers. That's why your parabolas work the way they do with pattern graphing, which is kind of cool to see. Why is he messing with you?
It's trying to be funny. Not funny.
All right, so let's walk through this first one. If it's under the radical, I can multiply it so I get root 100. What's root 100?
10.
Cool. You already just told me that one. This one, I have the squared on top and bottom. They're both perfect squares. The square root of 2/3. And then this one is also 2/3. So these are pretty much equivalent forms. That's the basic operation of radicals. If you have the radical of a whole fraction, it could be the radical at the top over the radical at the bottom.
You don't have that.
You don't have this page? Oh, okay. Where did that one fall into? Root, radical. It should be. Well, you're. Say, squeeze it on the side. I don't know where that went. I swear I printed everything. I thought I did. All right. Root 36, which is?
6.
Which you just told me is that. This can be, these are the two same things, so that can be broken over 4 over 5. Hopefully we have the next slide. Any questions on those? Just happy? Sorry about that. Don't know what I was thinking.
Man, I think those radicals are communists because they have radical roots.
Whoa,
I mean,
that's an accusation.
All right, properties of radicals. Do we have this page?
Maybe you're a communist.
Dude, I don't know where this page went. Come on, man.
Tell him to get it.
Just can't have nice things these days. All right. So, you can break up a radical. I know you don't have this page. I'm so sorry. You can break up the radical. Same idea. These are the two properties. So, I think you have seen those before. If you haven't, I apologize. Can I move on? Okay. You have this, at least? Where do these pages go? Man, that's it. I just can't have nice things these days. Okay, the Radicand has no perfect squares, square factors other than 1, so that's how you simplify it. There's no radical in the denominator. The reason you can't have a radical in the denominator, you want to know what the real reason is that you can't have a square root in the denominator?
it looks bad.
No. Before you had calculators, it was really hard to go, because a fraction is division. So if you had, like, say, root 5 over root 7, it was really hard to divide root 7 into root 5 as long division. It's the only reason. Now people are like, no, there's other reasons. No, it isn't. All right, you have this one.
No.
No.
You have up to what?
We'll have 7.
All right.
7 to like
Let's do USA.
12.
All right, so squeeze this in the margins. Ready?
No.
I'm going to break this to this. Why am I breaking it to 9 times 5 and not 3 times 15?
Because
Because
it's perfect square.
I want the largest perfect square, so then I take the square root of 9, so I get 3 root 5. So again, just squeeze this in the margins. Root 80. 80 is the same thing as 16 times 5, I believe.
Yeah, 4 and 5.
So, why am I not going 4 times 20? Because 20 has a perfect square inside of it. So, break down 16 squared root of 16 is 4 root 5. Done. 700 is going to break up in 100 times 7, so that's 10 root 7. Good. Is that okay?
Yep.
242. This is going to break down to 2 times 121. Square root of 121 is 11.
22. Wait. Yeah, my bad.
It's 11 root 2, not 22.
Yeah.
So 11 square root 2, 11 root 2. This one, we can't have the radical on the bottom, but we're lucky that the bottom is a perfect square, so I just get this. But then we get to this one. This is the one that you want to make sure you know how to do. This is the same thing as root 2 over root 7. Agree?
Yeah.
From there, what you're going to do is this. You're going to multiply both top and bottom by the denominator. So on top you get root 2 times root 7, which is root 14. On bottom you get root 7 times root 7, which is root 49. Root 49 is 7. You cannot reduce outside to inside, meaning you can't reduce a number inside of a radical to outside of a radical. You can reduce inside to inside or outside to outside, but you can't cross barriers. Is that okay?
Yep.
Any questions?
No.
Can I move on? Okay. All right. So this is going to be root 25. Root 25 is just 5. This one is going to, I'm going to go outside, outside, inside, inside. So I get 8 times root 9. Root 9 is what? 9. What's the square root of 9?
3.
3. What's 8 times 3?
24.
Done. Does anyone need to see that written out?
Nope.
I will, just in case you get the shy kid saying, so I get that, which is the same thing as that, which is the same thing as that. Is that okay? Do you have this page?
Yeah.
Yeah.
Oh, cool. All right. Now, there's all kinds of ways that we can start going about these. Okay? Starting with number 9. Now, some of you are like, dude, 6 times 15, let's go with it. Okay? That's awesome. If you see it right there, right then and there. But this might be an easier way to do it. I'm going to put everything under the radical sign. Are you still with me?
Yep.
Everyone there? Break 6 down. Not 1 times 6, but?
3 times 2.
Okay. Agree?
Yeah.
Break 15 down, not as 1 times
5
15.
times 3.
Okay?
And you-
So do you all agree with that?
Yep.
Does anyone like, wait.
Nope.
All right. So,
3
what is
radical-
3 times 3?
9.
What's the square root of that?
3.
And then 2 times 5? So 3 root 10 is my answer. Okay? And again, I could go on number 10 and do the same thing, or I could try and multiply 21 and 35 and get some number that's way bigger than I want to deal with. So I'm going to put all this under the radical. So I get 3 times 7 is 21, and then 7 times 5 is 35. Agree?
Yeah.
So this should be able to say my answer is 7 root 15. I can't break 15 down as any perfect squares other than 1 times itself. Is that okay? Everybody happy?
Yep.
Okay, problem number 11. You have to multiply what's outside to outside. Now this one will work out nicely because I'm going to get 15 root 36. The reason I did break that down is I realized 12 times 3 is a perfect square. Square root of 36 is 6. So that's 6 times 15. 6 times 15 is 90. Now when I get to this one, I can do a couple of things. Some people say multiply both top and bottom by root 12. Cool. But what's a perfect square that 12 would go into? Not 12 broken down into perfect squares. 144 is right, but what's Steven's following? 36? So if I can make that 36, I have a perfect square on bottom. Agree? Which means I'm going to multiply both top and bottom by root 3 and root 3. If you multiply on top, you can multiply on bottom. It does not change the fraction. So then I get root 3 times root 3, which is 9, right? And that's root 36, which is 6. And then I can reduce this as 3 over 2. Now, other ways that this could have been looked at, I'm just trying to give you some options. Remember I said you could reduce inside and outside? 3 goes into 12 how many times? 4. So that's going to give me root 1 over 2. Wait a minute. I goofed up someplace.
Shouldn't it be 3?
That should be a 3. Thank you. And then that gives me the 1/2. Sorry about that. I'm not listening to everybody. Then I have square root of 1, which is 1. Square root of 4, which is 2. So again, they both work out nicely. Which way do you want to do it? I don't care. Just not your neighbor's paper way. Yeah.
You can't have negatives under a radical.
Oh, we're getting there. Don't you worry. We will get there. All right. Can I move on?
Yeah.
Do you have this slide?
Yeah.
Oh, cool. All right. Hey, how many x plus 4s are we multiplying together?
2.
2 of them. So is x plus 4 quantity squared a perfect square?
Yes.
So that just means that this answer is x plus 4. We're done. Because the radical and this cancel each other out. Now this one, I know square root of 16 is 4. And the square root of this, because of that, is just going to be 2x minus 7. I'd say leave it like that. Some of you might be like, hey, can I have 8x minus 28? Sure. Is it right or wrong? It's correct. Which do you prefer? I don't care. It's your choice. Do you guys have number 15 as your next slide?
Yeah.
Can I move on? Am I going too fast for anybody?
No.
All right. So this is my whole thing. We're going to use FOIL. I know Common Core says, no, it's double distribute. FOIL is this. Ready? Same thing as double distribute. 2 times 2, 4. Still with me?
Yes.
2 times that is plus 2 root 3. That is minus 2 root 3. And that times that is negative root 9, which is negative 3. These cancel. 4 minus 3 is 1. These are actually known as conjugates of each other. They are the exact same binomial with one sign different. The middle terms always fall out. This is not a conjugate because it's not opposite signs. So if I FOIL this, I get 16 minus 4 root 5 minus 4 root 5 minus root 5 times root 5, which is root 25, which is 5. 16 minus that is 11 minus 8 root 5, done. Where did I lose you? Okay if I did. I won't make fun of you that much. I'll at least laugh behind your back. What?
So,
No.
it's not like 8 root 10?
No. You can't multiply, or when you are just multiplying a number times a radical, it just combines together. It's like 4 times x is 4x.
Yeah.
Same idea. All right. Don't give me my time. All right, this one, 49 plus 7 root 3 is 14 root 3. Root 3 times root 3 is root 9, which is 3. Combine your like terms, so I get 52 plus 14 root 3.
What's that? Easy.
Are these conjugates?
Yeah.
So if they're conjugates, first number, last number, done.
Neat.
Where'd the middle terms go? They canceled each other out. Square root 4. Because root 2 times root 2 is root 4, square root of 4. Okay? Getting close. Ready?
Yep.
You have that slide.
Yeah.
Do you agree?
Yep.
8 plus 6.
So notice I did what was under the radical mathematically first. Agree? Why didn't I just add those together? Because you can't. It's like saying, what's x plus y? X plus y. You have 2 completely different radicals. You happen to have 2 perfect square roots. Good stuff. And then this is 5 minus 4, which is 1. Conclusion? I don't know. Or does that say concussion? I don't know. Good. Good to move on?
Yeah.
I think I have almost time to show.
Give us more room on that.
All right. What?
They need to give us more room to work on that.
We'll get right on it.
No.
Yeah.
Good job, Hannah. Thank you, I'm proud of just
All right. These are like terms because they have the same radical, so you can just go ahead and add. So that's 9 root 3. Again, that's like saying 4x plus 5x. You just add them together. Then this one is 5 root 6. Awesome. This one just is it's done. You can try these on your calculator if you want. And that. Is there one last slide?
Yeah.
Of course, I probably have 12 in between. All right, root 75 is the same thing as 25 times 3, so that's 5 root 3, plus square root of 50 is 25 times 2, which is 5 root 2. You cannot go any further than that, because the roots are different. 12 breaks down,
2 squared.
so that's going to be 6 root 3. Did I do that right?
Yeah.
Minus 27 is 9 times 3, which is 3 root 3. I can indeed subtract those because you have the same radicals. Okay? All right. If you have a calculator, get it out. So,
I don't know.
so your homework for Monday, due Monday, is worksheet I, right? All right. If you have a calculator, I need you to do me this. Ready? Ready? Because we're talking about perfect squares. I don't know if you've ever seen this trick, but this is so cool. Ready? So let's say I have 98 squared. That's going to be, I can do it, 16, 92, or 90, is it 96, 16?
96.
9604.
9604. Why?
Okay, hang on. I can do this. I got to remember the trick. Okay, 95 squared. Okay, so 25 is my last two numbers. Is that right?
No.
No?
You suck at this.
All right, ignore my new trick. I had some that I gotta remember how to do it. There was a quick trick, but so test tomorrow or quiz tomorrow. There's a couple of you that got a selfie with me at homecoming, so you could just bomb it. I didn't see you. I'm just kidding.
Yeah.
We good? Everyone happy? You all taking care of one another?